it's often seen as something quite temporary, and the lifespan of wood is thought of as a couple of decades. But this is not the whole picture. In Japan, they've had temples for hundreds and hundreds of years. Of course, the oldest temples they have been rebuilt a couple of times already. So they're built using this technique where you can replace pieces and elements. And in a similar way, in the Finnish culture, we have had these log house structures that are like the ultimate circular economy way of construction, where a single piece of log can be taken apart and then moved into new places. And that's also a strong part of our cultural heritage. But a brief introduction. I'm an architect. I used to run an office called Pekka Pakkanen for 12 years. And in that office, some of the projects I was running, I was the chief designer of Ala Seapool in Helsinki. I was the local partner and the chief designer of Serlakis Museum in Mäntä, and the local partner of the winning entry for the Guggenheim Helsinki competition. That was the biggest architectural competition at that time. It had more than 1,000 entries. And I'm teaching timber architecture in Aalto University as a part-time teacher. The way that the reason I started my present office called Planetary Architecture was that I hit a wall of meaninglessness maybe some 5 years ago. Our office was doing sort of high-class architects, but it didn't feel like the things we were doing was answering the biggest questions that actually our generation should be tackling. And I thought there was a real issue that there needs to be. We can affect quite large. Like the effect of the architects and the construction field is huge, and I think we should use that to the benefit of both the planet and ourselves and the future of mankind, the humankind. And in this path of thought, I just had to leave the previous office because the sort of route was fixed, and I had to find something new. And in this, as a starting point for this new path, we took part in an innovation competition in Silicon Valley. It's called the organizer is called XPRIZE Foundation, and they had this huge science competition called Feeding the Next Billion, asking of what would be the answer. How do we develop the food systems to provide food for the next billion people that will be here in 12 years? And our task was not to sort of really solve the issue, but define the question that the science community should answer. We did it. We took part in this competition for like 8 months, and we gathered a big team of scientists both from Finland and from California. And to our surprise, we managed to win this. And on this path, we happened to learn quite a lot of the future food production techniques. And of course, the idea was how this knowledge, how could we mix this with architecture, like the knowledge that I had previously. And from that starting point, I started the office called Planetary Architecture. And the point of why we call it planetary is that in every project we see the planet as one of the clients. Of course, the planet doesn't have a voice, so we had to imagine that. It was one of the first projects for Solar Foods. That's a Finnish startup that is gathering CO2 from air, cooking it with bacteria, and producing protein, this protein powder that can be eaten. And we built a demo factory concept for them, and we tried to build this out of wood. And this was maybe the first learning from challenges of wood, that in an industrial environment, it's actually quite impossible to have timber structures as the fire hazards are quite heavy. So we did a lot of study for how could this be built of wood, but in the end we just figured out that it was impossible. As in the next case for the Neste oil company, they organized an open competition for ideas for the future gas stations. Once the oil is not being used to run cars, then what will they do with their network of gas stations? And our claim was that it should be a network of service stations, so it would be several different services that would be prefabricated timber units that are placed on the plot. And one special idea in this was that the oil and the diesel and the gasoline tanks are not hidden underground, so there's no risk of leakage, but they are hidden in this timber box in the center of the courtyard, and actually timber is being used here as fire protection material. So there's such a heavy layer of CLT that it prevents the fire from starting. Once the fire starts, then of course that's a different issue. But fire issues are somehow really elemental for wood, and most of these issues are not actually usually seen in the light of the facts, because the wood, like solid wood, can be really difficult to get burning. But once it burns, of course, there's not much to do about it. Another issue or challenge with the use of wood is once you use it really heavily, like in the case of a parking garage, how would that be built out of wood? And as if you see parking garage as like archetypal piece of construction, it's like the element that it is something that is like the most simple structure, that where you cannot really take anything out, and it's also the one that has to be built the cheapest. So we made this parking house concept for the cities of Helsinki and Vantaa, keeping in mind that it should be as cheap as a concrete structure, and it should be something that can be taken apart, that you can add floors, that you can have it like with prefabricated modular units that wears a limited amount of different modules. And in the end, we managed to build this system so that it takes all the weather load. The facades are built of Akoya that has a lifespan of 50 years, and on the inside, all the structures are completely solid wood. Solid, this thin layer of moisture barrier on the floors that is not wood. And these two samples for Helsinki and Vantaa, it looks like the Helsinki model will be built out of concrete, because they're used to doing that. This is one of the challenges of the use of wood, that as you try to bring something new to the market, it's always, there's a big challenge of changing the system, because the construction is about risk management, and the risks are easily managed in the way that people do what they have been used to doing. But in Vantaa, it might be that they built this first pilot project for the timber parking house. And in this path of thought of the long lifespan, if you imagine this first image of the Japanese temple where pieces can be replaced, then this is something that's really typical for timber, that it has mechanical joints. So if you build an office building, you can build it out of separate units that first of all, they have this 50-year lifespan, but once these elements are at the end of their lifespan, they can be replaced. And in this mechanical way of joining pieces, you can also you can expand the building. So this is the headquarters of Verso Wood that we're designing in Vierumäki in southern Finland. And it's a building that is designed to be 2,400 square meters once it's built, but then it can be extended in 3 directions using these similar modular pieces. And this is the inside of the building. It's in a quite an early design stage, so now we just have the concept of building this forest of timber columns that continues the forest of the outside, and then around this there's a little dense park-like forest where this sits, and this is looking outside all the time to the forest and to the roots of the timber industry. And speaking of lifespan, one way to extend the lifespan is, of course, to reuse the pieces. But another way, in addition to that, is that these pieces can be recycled in the first place. This is an experimental future street project we did for the city of Espoo last summer, and there was lots of thoughts of how the street could be used. But maybe this is, as we speak more of wood, this is this little street pavilion that we built for this exhibition or this demo street, and all these construction elements are recycled already. So that the vertical parts are from bridge construction site, and the horizontal ones are from packaging industry, and the glasses or the glazing is from office buildings. This inside office glass walls that were taken from one construction site, and all of these units have been already put into pieces and recycled. So there's sort of nothing left of this whole construction. So these pieces continue their life in different uses. Another quite central theme, I've been mentioning the fire, the heavy usage, the costs, and the lifespan of wood. But then there's this issue of the moisture that is something that is very typical for wood, or typical in wood construction, that you have to be aware of this, that there's the wood should not be used in too dry environment, but not in a too moist environment either. So we have made a couple of studies of building houses inside greenhouses. So this is a row house for the housing fair in Espoo, in Loviisa, just an hour and a half east from Tampere, east from Helsinki. And there's 3 apartments that are quite simple wooden CNT boxes, but they are placed inside a standard greenhouse. And the idea in this is that we have this not heated greenhouse that can, where you can grow your own food for 3/4 of the year, but you can also use this space for as an extension of your living room. And in this project, we learned that there's a bit of an issue with the moisture balance, that like in real serious professional greenhouse, the moisture percentage of the air should be something around 80%, and with wood, like 70 or 80 is more on the edge of the tolerance. So it should never be more, because then you might start having issues. And in this in a quite a similar sort of path of thinking, we built we have designed this concept for Y Foundation called the biodiversity building. This is an office, it's a housing block that has that is touching the ground as lightly as possible, and all of this is prefabricated. We're working on a plot to have first of these built in Helsinki in a couple of years. But the core of the concept is that we don't destroy the whole plot. We prefabricate it. We install the structures really lightly on light foundations, and then inside the building there's this warm timber hearth with the apartments, and then outside it there's a raincoat and a buffer zone with sort of a greenhouse on the top and wide corridors on one side. So by building it like this, if you have some real biodiversity and some real natural values on the plot, all of those don't have to be destroyed, and the living corridors can be used as sort of extension for the apartments, and it's a bit like this row house situation. And on the top floor we have the best views and the best light. This is the living area, or the sort of conventional courtyard, or replacing the conventional courtyard of the building. So there's the space for growing food, for playing, for getting together, and all of this. And as putting all of this together, if you need to deal with growing food or growing vegetables, growing whatever greenery, and build that out of wood, you should be using some other products than conventional CLT. And Pasi and Panu will be continuing from this topic, but this is something we did together with them. We built this concept for a single family house that would be built of these elements, and outside there's a covered roof terrace for growing your vegetables or just or having this like winter garden, and then there's another terrace for just extending the living room, and inside there's this timber world of open apartment that is quite light and super simple. And this modular house, and that's we have been sort of playing around with the concept of this and thinking of if we would take this into production and thinking of what would be the market of this, and maybe one thing to add in this is that in the core of the course is that in the basement there's a 50 square meter greenhouse built with these same elements or same units, and to have 50 square meters of vertical farming would provide the food, but not only the food but also the oxygen for such an apartment. So it would be like the first oxygen independent apartment building sort of technology, and I think there's quite a lot of very special potential and promise in the element of this, but let's hear more from the inventors of that themselves. So thank you.